Hey guys, before we jump into our first lesson this week, I just wanted to thank you guys, all of you who put in work last week, who started early, finished on time, and even the ones who maybe were a little late in getting to some stuff. I still appreciate you working on that. I know this first week has been crazy. Uh, Between you guys and me, technology, it's been a little bit of a challenge, but it's been fun to kind of learn and to get better and to roll with the punches. And I've seen so many of you guys be like, hey, I know this isn't working right now, but I'm going to do what I need to do. I'm going to get it done. I'm going to ask questions. I'm going to email Mr. Harris at 8:30 at night because you care. And I will never fault you for caring. And so I just wanted to make sure I discussed that before we jump into this lesson. There's probably still going to be some issues this week too, but know that we're going to keep getting better, and we just got to stick together and make sure that we help each other out as much as we can. So I just wanted to say thank you guys, and let's make this next week even better. All right, guys, today we get away a little bit from the geometry side of things and talk a little bit more about the algebra side. And for people like me who love algebra, even more than geometry, as much as I am growing to love geometry, I always love taking a look at this stuff. But just because we're getting back into a little bit more algebra does not mean we're still not dealing with geometry. In fact, look at our topic today: distance and midpoints. Now, even though these are both geometric topics, we know that we work these using algebra, or at least some of us do. Some of you guys may never have seen these two formulas we're going to be discussing today. But you can go ahead and pause the video if you want, just to go ahead and read over what our two standards are going to be today. All right. So two big things here: being able to apply the midpoint and distance formula to points and segments in order to find missing information, and one that I'm going to really focus on here for a second, understanding and being able to define how we find distance and midpoint along a point and a line when we are talking about a plane. Now, quick reminder, guys, what is a coordinate plane? When we say plane, we're not talking about the one with wings. What is a coordinate plane? Well, some of you guys probably remember. It has an X and a Y axis, and it is divided up into four quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And in fact, it kind of, if you ever forget how to keep track of which quadrant's which, it actually forms a C. 1, 2, 3, 4. And the reason I bring that up is because anytime we're using the midpoint and distance formulas, this is virtually always going to be when we are in a coordinate plane. And how do we know that? We'll take a look at both of these terms, midpoint and distance. What's something they have in common? X1, X2, Y1, Y2. That's because these have to deal with coordinate points. These are where these points are on the coordinate plane. And we're going to get more into that on the last 2 pages of this day. But before we really dive into the heavy math, let's kind of see how we can apply distance and midpoint in a little bit simpler context. Because a coordinate plane, in general, is not the only place you might see distance. In fact, you'll see it down here on a number line. But first, take a moment. You can pause the video, and let's read over these 3 terms right here. So you can go ahead and pause. Okay, first one, the ruler postulate. This is not one we're going to spend a ton of time on. The big thing here is that when you have a line, every point on that line has value. So every point on that line has value. How about a definition we've seen before? Segment addition postulate. Sometimes we see this as seg add post. So in other words, part plus part equals the whole. So we can very easily draw an example here. If we have AB plus BC equals AC, we know A and C are our endpoints. We're told if B is between A and C, we don't know where. I'll put it here. Then you have part AB plus part BC equals the whole segment. And that's actually what your delta math is over. So hopefully you've been able to get that knocked out when it comes to seg add post. That is the definition of your delta math assignment from this past week. And the one we're really going to dive into now is distance. Distance can occur on the coordinate plane. In fact, we know if we're using the distance formula, it will be on the coordinate plane. But it can also occur on a number line. And if it does occur on a number line, it is much easier. And one thing to remember about distance, and I cannot stress this enough, think real world with distance. It must be positive. You can't drive -5 miles, right? You can't swim a quarter of a mile, or a negative quarter of a mile, I'm sorry. Even if you swim quote unquote backwards, you're still traveling a positive distance. So distance will always be positive. And you're my accelerated class, guys. I'm not going to do these points for you. I know you guys can get these knocked out. So you can pause the video if you want. And when it gets unpaused, we'll have all these points here, and we'll just make sure they're all in the right spot. All right, just take a moment to make sure everything looks good, that our pictures line up together. And so why do you think distance is a lot easier on a number line? Think about that for a second. And the reason is because you don't have to worry about any vertical change in distance. When it comes to a number line, the only way distance is achieved is right or left. And that is really, really easy to quantify because that's just one-dimensional. We're either going right or we're going left. There's no vertical. So what I'm going to let you guys do, once again, you're my accelerated class, is I'm going to let you guys see if you can label using the measure of units. See if you can label what the distance is between each of these points. Because AD, for example, A to D, that's actually a line segment from A to D. And so you count how long that line segment is. So 1, 2, 3, 4, 5 units. And so guys, I just want you to go through, see if you can do numbers 2 through 6 for me. So check your work here, guys. Looks like H to A might be the only tricky one for some people, but actually it's not too bad because we see -6 and 6. Well, you go 6 to get to 0, and then you go 6 to get to 6. 6 plus 6 gives you 12. So if you need to take a moment to stretch, pause, do what you need to do, but we're about to hit it. We're about to get into some of the heavier stuff, so just get ready. So unlike with a number line, distance gets a little bit more complicated on a coordinate plane. Because now not only do we have to measure the distance something is going horizontally, but also vertically, to where now we have what's called diagonal distance. And anytime you have diagonal distance, it's something you can't just do an eye test on, like we did with that number line. You can't just look at this from P to Q and say, oh yeah, that's 9 units away from each other, because you just can't tell. There's no straight line measurement here. And so what we do is, if we want to find the distance, we have to bust out the distance formula. And I know that can be something that looks a little scary, but it's actually very repetitive and pretty straightforward once you do the most important part in finding distance. When it comes to distance, you must, it is a must with 3 underlines, label. Because guys, x2, x1, y2, y1, all of that can be completely confusing if you do not have points labeled. I want to remind you, when we're looking at a point, it is made up of 2 components. when we're on the coordinate plane. A point is made up of where it is on the x-axis. So like looking at, let's start with P. P is at, on the x-axis, 6. That's where it lies. So that is for the x. And then from there we would go, okay, if it's on 6 on the x-axis, where is it at on the y-axis? Well, it looks like 1, 2. So a point is made up of an x-coordinate and a y-coordinate. And actually, let's go ahead and label P. P is 6, 2. Now I'm going to give you the chance. See if you can label Q for me. We are left 4 and then down 6. -4, -6. So we have both our coordinates labeled, which is the most important thing, especially starting off. So now, how do we know where to plug what into these points, into this distance formula? Well, let's come down here, guys. Looks like PQ is how they have this labeled. So you're going to notice 1s and 2s. All those mean are our first and second point. You can label those however you want. But here's the thing, whether it's the distance formula or the midpoint formula, we are going to have to make sure that we keep the first point's coordinates together, x1, y1, and the second point's coordinates together, x2, y2. That is where all of this comes from, guys. So, for example, they label P first. So I'm going to write P's coordinates again, 6, 2 is P, and Q was -4, -6. And since we labeled P first, P is going to be our first point. That means it's going to have the first x coordinate and the first y coordinate. And so some of you guys know that must mean for Q, that's going to be the second x coordinate and the second y coordinate. And so once we have these labeled, some of you guys are probably thinking, oh, it's just plugging these numbers in and working out what's underneath. And that is absolutely correct. But we got to make sure we plug these in carefully. So I'm going to come over here. We got distance. Let me change up the color here. Keep you on your toes. We got distance, we're going red, is going to be the square root of, okay, x2 minus x1. Well, we know we labeled x2 as -4 minus x1, which we labeled as 6, squared, plus, next up, y2 minus y1. So -6 minus 2 squared. And from here, guys, I cannot stress enough, we got to remember PEMDAS. We're going to do what's inside the parentheses before we deal with that exponent. So -4 and -6, add those together, combine them, you get -10. Plus, and it's okay to take this one step at a time. You don't have to solve this all out in one step. Plus, -6 minus 2, looking at -8. And from here, remember what happens anytime you square a number. And this goes back to what we said about distance. Distance is always positive. And so whatever numbers you end up getting out of this should always be positive at this point. -10 squared, -10 times -10 is 100, plus -8 times -8 is positive 64. And so we end up with the square root of 100, yikes, 164. Now, units. Now that could be an answer, sure. But what if we wanted to get a little bit better picture as to around what that value really is? Well, you can just take the square root, guys. You do that on the calculator. The square root of 164, and I'll round that to the 10th, so to the first decimal point. And when I do, this isn't an exact answer, it's an approximate answer, so I'm going to use these wavy approximate signs. we get 12.8 units. So we can look up here and say, okay, P from P to Q is about 12.8 units, close to 13 units apart. And so here comes the big part, guys. I'm going to let you see if you can do this number one for me, where they already have the points labeled, so you don't have to worry about that. Give this your best shot, guys. Take your time, and you can go ahead and pause the video. Okay, this time I decided to hold off on finishing the problem. I know some of you guys hopefully already have and you've done it correctly, but I just wanted to point out one thing to you that if you ended up getting the wrong answer here will be the reason why. We see we have 5 minus -7. What happens when you subtract a negative? That really becomes a plus. This is really 5 plus 7, double negative situation. So if you didn't get 12 squared there, that is probably what messed you up. And I can already hear some of my former students, Dan and Gia, saying right now, hey, do we have to show all these steps if I can just do a lot of this mental math? The answer is no, you don't. But for a lot of us, if we make mistakes, it's because we rush through and we don't make sure that our math is accurate. We don't make sure that each step where we're adding or squaring is accurate. It's really easy to make a mistake sometimes if you're not able to write it out and look at it to make sure things are going well. But that is up to you guys. I will leave it up to your discretion as far as how many steps you show, but you do need to show at least 1 or 2 so that I can see that, oh, they actually understand how they got from here to here. Otherwise, you know, there's some nefarious thoughts I could have as far as how you were able to get an answer if you didn't show your work. And I'd like to think none of you guys would need to resort to anything like that. We've been all about distance so far, but on this last page of our lesson, that's right, the last page, I thought we'd take a look at the other topic that we first brought up at the beginning of this day, midpoint. And for me, I think midpoint is a little bit simpler. Just because of number one, the formula, and number two, the concept in general. With a midpoint, it's less about that whole diagonal distance thing, and it's more about just thinking about halfway betwixt. We're talking, you know, just where is a point based off where the points on both sides of it are. And here's something to make sure you don't get mistaken by. Midpoints can be negative answers because clearly you can have points that lay in a quadrant that has negative values. That's absolutely possible. And so we see here we have a number line label. A midpoint is just going to be the point that lies in between a segment. So for example, on RT, we're going to use this number line to find the coordinate of the midpoint. So for RT, we're looking at this segment right here. What points or value, if there is no point there, would be the midpoint of RT? So RT is 6 spaces long, -2 to 4. So it should fall 3 spaces in on both sides. 1, 2, boom, 3. We're talking point S would be that. And so I know a lot of you guys are thinking, okay, I can handle this, no problem. And so I'm going to let you. Go ahead and try numbers 2, 3, and 4 for me. See if you can find what value or what point lie in the middle of each of these segments. And some of you guys probably had no worries about getting decimals here, because if a midpoint falls between two whole numbers, it is going to be the halfway point between those 2 whole numbers. So S and T, we see it falls between 2 and 3, so it's going to be 2.5. PR, that falls between -6 and -5, so it's going to be -5.5. And then a lot like the distance formula, we know that when it comes to finding the coordinates of the midpoint, it's all going to come down to those x1, x2, y1, y2. But this time, we're actually going to see some quote-unquote fractions, but not really a scary fraction. When I say fraction, we're just going to be dividing some answers by 2. But again, most important thing, what should we always do first when dealing with midpoint and distance? That's right. We got a label. Label, label, label. So what's our x1? Well, looks like they listed w first, so I'll call that x1. You didn't have to. I could have called negative 8x1, but whichever one I go with, I have to stick with. So if that's x1, guess what negative 7 is going to be? Not x2, but y1. Be very careful there, guys. Very common mistake. Every point has an x and a y, not two x's or two y's. That makes t x2 and negative 4 y2. And you're going to see the math here is a lot simpler. Midpoint is going to be x1 plus x2. So in this case, we know we're dealing with a point, so we should have parentheses and two spaces here. So first we're going to have x. So negative 12 plus negative 8 over 2, and negative 7 plus negative 4 over 2. And whenever you work these out, we know negative 12 plus negative 8 is negative 20. Divide that by 2. You get negative 10 for x. And then negative 7 plus negative 4 is negative 11. And negative 11 cut in half. Hey, we saw that number earlier. You're looking at negative 5.5. And so you're going to notice no units here because we're not talking about a distance. We're talking about what point falls between W and C. Turns out that this point right here would fall between these two. So it would look a little something like this. That's kind of where that point would fall if we were looking at this line segment. It falls right in the middle. And instead of making you guys do kind of another problem a little bit like this, trust me, you'll get some practice on the next page with your practice multiple choice homework. But instead of kind of doing that, I wanted to switch it up a little bit here. How about if we're looking at a line segment DF, but we're actually given the midpoint this time. So we're told E is the midpoint. And we're told F is one of the endpoints, but we have to find the coordinates of the missing endpoint. D is missing here. So what we know we're going to have, we know we have, looks like F at 5.8, just giving you kind of an idea of what this might look like. We know E is going to be at 4.3. And the question is, where will point D be at? What will its coordinates be? What will this endpoint be? Because we can tell, obviously, 5.8, 4.3, we're heading down and to the left because the x is getting smaller and the y is getting smaller if F is an endpoint and E is our midpoint. So we know D should have an x that is smaller than 5 and 4 and a y that is smaller than 8 and 3. And here's the thing. We can cheat a little here. Don't anybody tell you I said that, or don't tell anybody. But if we know that from F to E, to get to the midpoint, the x just goes to the left one, what can we see about y? From F to E, we went down from 8 to 3. So we went down, how many is that? 8 minus 3 is 5. So we went left 1 and down 5 to get from an endpoint to a midpoint. So what are you guys thinking from that midpoint to our other endpoint? Same thing. Left 1, down 5. So we went from 5 to 4. That's left 1. How about if we subtract 1 from 4? We know D is going to have an x coordinate. Ooh, point D, my bad. Put the point on the wrong side. It's going to have an x coordinate of 3. How about if you go down 5 from 3? Ooh, we're going to get into the negatives there. Take a second. What would be the y coordinate if you went down 5 from 3 on the y-axis? Down 5 would be negative 2. And so there would be our endpoint. So guys, I know this was a little bit heavier math day, but thank you for sticking with me. I'd say those of you who are more algebra minded felt right at home. You guys were crushing it today. And I'm kind of with you there. I always like doing a little bit more algebra myself. So before I go, flip over to this next page. And so, just a reminder, we are going to do this is going to be our homework. And once again, I thought I'd have some fun with it. We are going to have a quizzes assignment. So we will have a quizzes assignment over multiple choice, 1 through 6. Hopefully you guys will have some fun in that. Again, shout out to our winners of our first quizzes. And I'm looking forward to announcing who gets the virtual Jolly Rancher and hand claps of praise for this next one. So thank you guys very much. Get this knocked out. Make sure you have your Delta Math done. And let's keep this week rolling. It's going to be a great week.